Welcome students. So this is the next video, right? On chapter 2. This is what part 2 video. So you should watch part 1 before you come and watch part 2. So let us see the price of eggs and the price of a college education revisited. Remember, we said that we calculated price of eggs, and we saw that since 1960s, right, we saw that real price of eggs decrease, but real price of college education increased many times more. So from 1970s to 2010, the real constant dollar price of eggs fell by 55%. In that example in chapter 1, we discussed this. While the real price of college education rose by 82%. Let us say now we want to know what is going on. Why is price of egg decreasing and why price of college education is increasing? The mechanization of poultry farms sharply reduced the cost of producing eggs. See, technology has changed in the industry, poultry industry shifts, and also shifts the supply, and because of this the supply curve shift downward to the right, and so this is one thing. This is the change on the supply side, and on the demand side the demand curve for eggs shifts to the left as more health conscious population tended to avoid eggs, right? Eggs, they say, have cholesterol, so they want to so physician so healthy diet, often people say now, is that eat more, eat less eggs. So what is happening in the egg market? We can see that supply is increasing, supply up arrow, but demand is decreasing, demand down arrow. People switch to more healthy alternative then. Now, what about college students? College education, as for college, increase in cost of equipping and maintaining modern classrooms, laboratories, and libraries, along with increasing faculty salary, push the supply curve up. See that? Push the supply curve up, and as a result, what happened? Cost of production increases here, right? All of these are components of cost, right? And salary, faculty salary. And this will what? Shift the supply curve up. We know that supply will shift to the left. On the other hand, demand for college education, what happened? The demand curve shifts to the right as larger percentage of a growing number of high school graduate decided that a college education was essential. So demand increases here. Let us say demand increases for college education, but supply decreases. Cost is higher than before. So supply curve goes left and demand goes to the right. And on the other hand, for the egg industry, supply curve goes to the right and demand goes to the left. So this is market for eggs. See, so the solid line, this one is supply 1970, demand 1970, right? And then supply curve, supply is 2010, right? This supply 2010 increases, right? Remember, improvement in poultry industry, but demand decreases. See that? From 1970 to 2010, the demand curve, demand decreases. So so 40 years, over 40 years, this is how market for eggs changing. So initially equilibrium was at this point, right? So this is 0.61, right, and 5300, and for this one is what is 0.27 equilibrium price, the new, and this is what. So here price will decrease, and what? Price will decrease and quantity will increase. On the other hand, market for college education, look at that. So this is the initial 1970 demand, 1970 supply, right? and this is the equilibrium price, and this is quantity. And on the other hand, what happened? Now we know that people demand more education, demand increase, but what happened? Cost increased because of higher cost of equipment and what's faculty salary. So here, so this is the new demand in 2010. This is new supply in 2010. So this is the new equilibrium, right? Okay. And look at that. Here you can see easily that cost of college education is increased. So you see, now thanks to the market model, we can now clearly understand that why between 1970s and 2010 price of eggs decreased, equilibrium price of egg decreased, and equilibrium price of college education increased. This was because of what? Shifts of the demand curves and supply curves. Let us now discuss again the wage inequality in the United States. Over the past 2 decades, the wage of skilled high-income workers have grown substantially, while the wage of unskilled low-income workers have fallen slightly, right? Okay. Now we see these are two groups. We want to know what happened for skilled, demand supply for skilled workers and demand supply for unskilled or low-income workers. So from 1978 to 2009, people in the top 20% of income distribution experience an income increase in the average real inflation adjusted pre-tax household income for 45%, while those in the bottom 20% saw their average real pre-tax income increase by only 4%. See, it's both increase, but one increase 45, another is 4. Of course, that high income people have to pay more tax, but even after adjusting for that, we can see that what the 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 so we can see that income for the top 20%, right, increased much more than the income of the bottom 20%. So what happened? Why? How do we explain this? While the supply of unskilled workers, people with limited education, has grown substantially, the demand for them has risen only slightly. See, so demand did not increase much, but supply increased a lot for these unskilled low income workers, right? This for this group, low income unskilled workers. On the other hand, while the supply of skilled workers, right, like engineers, scientists, managers, and economists, has grown slowly because it takes a long time, right? So years of education and training and experience, on the job training, and what professional certification to become an engineer, scientist, or managers. So the supply does not grow quickly. Supply grows slowly. On the other hand, the demand has risen dramatically, and this has pushed wages up. So that is the reason for what? One explanation, this change in the demand and supply for the two group of people, right? Skilled, high income, demand increase and supply did not increase much, right? And for unskilled, low income is what? Supply increased much and demand has increased only little. So let us show you. Because of that, we see the difference. Now, example 2.3, 2.3, the long run behavior of natural resources. Look what is happening. You see, consumption increasing, consumption and price of copper. So although annual consumption of copper has increased about 100-fold, the real inflation adjusted price has not changed much, right? So what is the reason for this? Long run behavior of natural resources, not just copper, for some other resources also. See, look at that, 1990s, 1900, 1950 and 2000 demand curve, and look at supply, 1900, 1950 and 2000 supply curve. Look, demand is increasing, but supply is increasing much more. Although demand for most resources has increased dramatically over the past century, prices have fallen or risen only slightly. The real inflation adjusted rate because have shifted terms because cost reductions have shifted the supply curve to the right just dramatically. See, cost reduction means what? Find new mineral deposits, right? And also improvement in technology, improvement in communication and transportation. Because of all of that, look at that. Supply shift much higher than what? Demand, and as a result, if you compare equilibrium, price is decreasing. So those are the short run supply curve for decades, but if you take all of them together, long run path of price and consumption, you'll see that it is what? Going down over time, because supply is shifting more and more, becoming improvement in technology and increase in the in the supply of resources. So as technology improve, they can detect more and more copper mines, right? And extract copper ores from there and produce copper. Now later we want to discuss the, the next concept, elasticity of supply and demand. So elasticity, what is elasticity? Elasticity in very simple word is percentage change in one variable resulting from a 1% change in another. So one variable, suppose x, and 1% increase uh, and this is y, right? So elasticity then will tell us x and y will then tell us what? Percentage change is I'm using shorthand delta. Percentage change in a variable x divided by percentage change in y. See, that is the ratio elasticity between, excuse me, any two variable tells us. So price elasticity of demand, percentage change in quantity demanded for a good resulting from a 1% increase in its price. So see, so when these two variables is what? The variable in the numerator is what? Percentage change in quantity demanded divided by, right? So this division, right? Divided by this what? Percentage change in price. So we can rearrange and simplify like that. Percentage change in this percentage change in quantity, we can write delta Q over Q. And percentage change in price, we can write delta P over P. See that? We divide, we rearrange, we get this. So this is one example we want to show you. Look at that demand curve, that is a straight line, right? We often may simplify things, right? Quantity demanded, dependent variable depend on price. But when in economics, when we draw graphs, sometimes, especially if one is price, one of the variables in this one of the variables here involved in this relation is price, we will put what? Price on the vertical axis, see? And quantity on the horizontal axis. So this graph is actually what? Actually just let us see minus, so B and P we are solving, and A minus Q. So P equal to what? A divided by B minus Q divided by B. So this is the graph we are showing you here. Linear demand curve, the price elasticity of demand depends not only on the slope of the demand curve, but also on the price of the quantity. See that? So here, look at the slope of the demand curve. If you go to the previous example of demand, we said what? Remember, when we simplify, we have dq over dp and p over q. So this is the slope of the demand curve, right? For this, that is the slope. So we can see that if this is the demand curve, elasticity will depend on the slope of the demand curve, but also on the price and quantity where we are measuring. So the elasticity therefore varies along the curve as price and quantity change. So if we are measuring elasticity here or here or here and here, right? So this P and Q will change, right? So here for example, price is what, 4, and quantity demanded 0. Here on the other hand is what, at that corner price is 0 and quantity demanded is what, quantity demanded is 8. So see, those values of P and Q in the elasticity formula will change as we move along the demand curve, and as a result value of elasticity, that coefficient will change, right? Now the slope for this equation is minus b, and that is constant, that does not change, that slope. But because p is changing, q is changing, elasticity will change as we move, right? So here we will have, if you use this information to calculate elasticity, you see that elasticity is minus infinity, right? So how so? Let us see. Elasticity, we know that first is the price, so is the slope minus b, and then at that level, at that point is what? Price is 4 and quantity is what? 0. So this is minus 4b divided by 0 is what? So anything divided by 0 is infinite. 0 is so small, right? You can continue dividing until infinity. On the other hand, what is going on here? Here elasticity is what? Let us see. Minus b, the slope is the same, but here it is 0 divided by 8. See? Here p is 0 and q is 8. So if you divide 0 divided by 8, 0 doesn't have anything in it. So the result is undefined, right? Infinity. No, so this is 0. Sorry, the result will be 0 here. Here, this one is telling us 0. And right in the middle, in the midpoint, if price is 2 and what? Quantity demanded is 4, substitute those values, and you will see that elasticity will turn out to be 1. What about this one, linear demand curve? See, demand curve is flat, so we just have whatever is the demand, price is what, p star always. There is slope of this is 0, and as a result we say that, hey, price, demand is very high at price p star, but even if you change that price a little bit, there will be a big change in demand. So we say that here in this case, for horizontal demand curve, we say price elasticity of demand is infinite. So yeah, infinitely elastic demand. So principle that consumers will buy as much of a good as they can get at a single price, P star here, right? But for any other price, right, there is what? Demand drops to 0. While for any lower price, quantity demanded increases without limit. So here, for price higher than that is what? Demand is 0. For price lower than that, demand is what? Increases infinity. That is why this we say is infinitely elastic demand curve. Depending on the change in price, that elasticity will change from 0 to infinity. So hence infinite demand curve. Now what about this one? This is a vertical demand curve. Look at that. Whatever the price now, demand does not respond Q star, and as a result what happens? in this case we know that the vertical demand curve slope is 0. So here slope is 0, and because the quantity demanded is the same, no matter what the price, there is elasticity of demand is 0, right? So if you look at it this way, elasticity of demand we said is percentage change in demand divided by percentage change in price. So here demand does not change, so that percentage change in demand is 0, the numerator is 0. So whatever you have here, 0 divided by this is what? This is completely inelastic demand. Elasticity of demand will here be 0, see that? And here we say that slope, right? Slope that dq dp in our equation is what? Is infinity for a vertical line, 90, a right angle, forming a right angle over there. Completely inelastic demand, principle that consumers will buy a fixed quantity of a good regardless of its price. They always buy Q star. Now other type of elasticities, one is income elasticity of demand. In income elasticity of demand we have what? Percentage change in quantity and percentage change in income. And then what? I simplify and then cross price elasticity of demand is which one? Here. So this one will tell us how. Sorry. Before we go to the next one, let us see. This income elasticity will tell us what will be the percentage change in the demand for a commodity given a 1% increase in income, right? So and then the next concept, cross price elasticity. This tells us percentage change in the demand for one commodity. This is commodity B divided by percentage change in the price of M, right? So the percentage change in the demand for one commodity divided by percentage change in the price of M. So you divide, and this is what you get, 2.3. See that? See, we simplify and we get this. This one will tell us how demand will response how demand will change in response to a unit increase in price. So that now this is now here we want to say is that if these two goods are if these two goods are substitutes, right? If they are substitutes, then we know that when price of substitute increases, like price of Coke increases, demand for Pepsi will also increase. So for substitute goods, this and then complement. And then what about complement? Complement is what? This is what? Less than 0. Okay. Now complement is that like a DVD player and DVD, right? So that means that when price of DVD player decreases, people buy more DVD. So you see price will percentage decrease in price associated with the what of DVD player will be associated with an increase in the demand for what? For DVDs, right? So an opposite in percentage change in opposite direction. So hence we will, if you calculate, you will see that elasticity for complements will be less than 0. And if they are okay, Okay, now what happens? Now elasticities of supply, price elasticity of supply. This is so far we have discussed different elasticities of demand, different type of elasticities of demand. Now what about the elasticity of supply? This one tells us what will be the percentage change in supply given a 1% increase in given a 1% increase in percentage change in quantity supplied and percentage change in price, right? So see, so this one will tell us what will be the percentage change in the supply of a commodity given a 1% change in the price of the product. So they are not showing, but we can show you this percentage change in supply. You can measure as change in quantity divided by Q. Percentage change in price you can show as change in price divided by price, right? And then let us simplify. If you simplify, you will see that end up eventually you will end up with this one, just as before, right? There are different ways to measure this percentage change. This is one way, but there are other ways also. We will do some of those in the when we solve the exercise. Now, from point versus arc elasticity. Point elasticity is when we measure elasticity at a certain point. Point elasticity of demand, price elasticity at a particular point on the demand curve, right? So we are talking about a particular point. Arc elasticity of demand, arc elasticity of demand. So this is where we are want to, before we go to arc elasticity, point elasticity. So this is the demand curve. We want to measure demand at that point. See that? Price is P is price, Q is quantity at a particular point. So, so we often use calculus to get this kind of demand curve, point elasticity. What about arc elasticity? Suppose we have another situation where we want to measure demand over a wide range. What is elasticity between those 2 points? See that, this one and this one. So this is demand, this is quantity, you know that origin, and this is price. So when we have that arc, look at that arc between those 2 points, we call arc elasticity. For arc elasticity, this formula will be like what? You have, this is say P1 and P2, and this is Q1 and Q2. So here, look at that. P bar means that the average. P bar means that we take P1 just a minute please. P1 plus P2 divided by 2. See, and this Q is what? Q bar is what? Q1 plus Q2 divided by 2. So see, so here so when we are measuring percentage change, we are measuring with arc elasticity, and we measure the reference point we use is P bar, means the midpoint. We also call this the midpoint formula. A midpoint formula for measuring elasticity. Now, what about market for wheat? They are giving us example. Let us work with some demand and supply curve. This is for the American agriculture. During recent decades, changes in the wheat market had major implications for American farmers and US agricultural policy, right? Both for the government and the farmers. So to understand what happened, let's examine the behavior of supply and demand beginning 1981. So this is the supply, look at that. plus positive slope, right? And demand curve, this is negative slope, right? And what is the equilibrium? You know that the market clearing price for wheat for 1981 was is said demand equal to supply, and solved for P. Price of bushel was 3.46. Then that is the equilibrium price in 1981. And now substitute this one here. You can put it anywhere, demand supply, but let us say we put it in the supply equation right here and solve. This is the equilibrium quantity. See, so we have quantity, equilibrium, market clearing price, market clearing quantity. Now use the demand curve to find price elasticity of demand. So this is the formula, right? And this is the equilibrium price 3.46, equilibrium quantity 2630. We just calculated them in the previous slide, and from the equation of the demand curve you can see that this is what, minus 266, right? Minus 266 this. And if you solve, get this. Then price elasticity of demand, this one is inelastic. See that? Less than 1, inelastic. On the other hand, we can likewise calculate price elasticity of supply. This one also is inelastic, less than 1, right? Now because these supply and demand curves are linear, right, we simplify. The price elasticities will vary as we move along the curves, as we have already explained to you, right? Now one thing I want to discuss is about this elastic and inelastic. See, when we measure elasticity for a price elasticity of demand, if it is higher than 1, we call it elastic. If it is equal to 1, we call it inelastic. And if it is less than 1, as it is here, we call this what? Inelastic. So when it is elastic, that means that what? That means, remember the elasticity formula, look at that, this one. Let us see. Percentage change in quantity and percentage change in price. So if it is greater than 1, then that means numerator is higher than the denominator. So percentage change in price is associated with a larger percentage change in quantity. But if it is 1, we know that those two percentage changes are equal. If it is less than 1, we know that what? Percentage change in quantity is smaller than percentage change in price. See? So, or similarly for here we have this one, we have what? Let us say elasticity of supply, and this one we are saying again percentage change in quantity supplied divided by percentage change in price. So what happens now? So if it is less than 1, that means a 1% increase in price will cause a less than 1%. So here less than 1 means what? Again, the numerator is smaller than the denominator, right?